Okay, I want to review the homework that we did yesterday. That was a long assignment. I'll make sure you understand all the answers. And first, we were doing that tough box and whisker plot, right? That was tough. Why? Not because it was that hard necessarily. It was new, it's something we've never done before, and learning new things can be a challenge. So hopefully, understand it. We'll go through it again real quick. Remember, there's five things that you will always immediately see and recognize when you see a box and whisker plot, right? That's going to be the smallest number in the whole group of numbers you're talking about, and that's going to be the left end of your whisker over there. The greatest number is going to be the right end of the whisker. The median is going to be the line through the middle of the box. Okay, so the smallest number here is 0. One of those cans of sodas had 0 calories. The biggest number over here is 160, right? The most calories of all the cans that he looked at was 160 calories. The middle number, the median, is the middle of the box. Now, when I say the middle of the box, it's the line in the box. Sometimes that might be over here, right? It might not be in the center of the box. What it means is there are equal number of data points or numbers to the right of that line, wherever it is, as there are to the left. Okay, in this case, the median number of calories for all the sodas was 120. Okay, and the next two numbers that we're talking about are the outsides of the box. Okay, and what the outside of the right side of the box, what that represents is the median of the upper half of numbers, all the numbers that are more than 120 all the way to 160. That's the middle of those numbers. And the left side of the box of all the numbers between 0 all the way up to 120, the median, that is the median of the bottom group of numbers. Okay. And some people get confused and they see this longer span, and they think that means there's more numbers. No, that it's a wider range, but they're spread out more. Okay, so it's good to know that. Very cool way of representing data. One of the things that came up yesterday in one of our classes is the quote that a picture is worth 1,000 words. Okay, and to describe what's going on with all those numbers, it would take a lot of different ways. But if someone knows what a box and whisker plot is and how to read it, that simple picture tells them so much information, just like that. Okay, so it's kind of a valuable thing to know how to do, how to make, and how to read. Okay, all right. So we got pretty far on the order of operation problems on 852. Right? We did the parentheses first, and then we divided, and all that was left was that adding 1 plus 2 3/4 is 3 3/4. Okay? So, again, sometimes you put a box around your answer, box around all the work in the problem. This next one, we got to the point we had 3 times 3. We were going to do that, and the 2 times 7 before we did any addition. Now all that's left on this last line is 9 plus 6 plus 14. Okay? And that ends up being 29. Okay? Put a box around my problem, box around the answer, easy to find. All right, the next one we had 49 divided by 7 times 5 plus 4 times 5, 0.25. So that one I'm going to do 49 divided by 7, that's 7. And I got to do 7 times 5 plus 4 times 5 and a quarter. So I'm going to treat that like $5 bill and a quarter. Okay, 7 times 5 is 35, and 4 $5 bills is 20. 4 quarters is a whole dollar, so that's 21. And then all I have left is 35 plus 21, 56. Okay, and again, especially since this page is kind of crammed together, it's good to put a box around all your work and a small box around your answer. Okay, all right. All I had to do here was to, is that right? Add? Oh no, 853. Sorry, that wasn't that's a new problem. And the deal was here is they had two kids adding this, and one kid got this answer, one kid got this answer. Well, remember when you add decimals, the key is to stack them and line up the decimals. So I'm going to put that 3 underneath the 4 there. Now I add a 0 so it's not so confusing, and I get 8.72. Okay, so the kid, Maciel, is the one that looks like he did it right. Okay, how did this kid get 8.45? Any guesses? Most popular wrong thing. They didn't follow that number one rule when you add, and they just did 8.42 and 0.3, did not line up the decimals, right? And that's wrong. So that's what they did. We don't want to leave that there, because if we come back and look at it later, we might assume that, okay, that's how you do it. No, put a big X through it. You don't have to erase it. It's kind of cool to have a wrong answer with a line through it that tells you that's wrong. Okay. All right. We were looking for the area of this shape here. And the key to figuring that out is we had to figure out the missing numbers and then do it piece by piece, right? So this is a weird shape. I figured that the easiest way to get the area was to draw a line down here, get this big rectangle, which is 6 times 18. That's 6 tenths and 6 eighths. 6 tenths is 60, 6 eighths is 48, 60 and 48 equals 108. And again, area, we're talking square units, so square centimeters. This one was easy. It's just 9 times 9. That's 81. And again, we're talking square centimeters. So far I have 108 and 81. And this one was the hard one because we didn't know the dimensions of this rectangle. We knew that from here all the way across to here was 24. This part of it was 9, and this part of it was 6. So if I do 24 minus 9, I get 15. So this part from here to here is 15 minus the 6, okay, and I should get 9. Or add the 9 and the 6, get 15, and subtract it from 24. And that's the hint I gave you. 24 minus 15 ends up equaling 9. Okay? Okay, back. Sorry for that delay. Had to press pause on that for a little bit. So we get 9 when I subtract. So this is going to be 9 going this way. Okay? And I'm going to multiply that by the height. And how do I get the height? Well, this is 18, and this is 15. So this must be 18 minus 15, which is 3. So 3 times 9, this is going to be 27 square centimeters. All I do now is I add up this rectangle, and this rectangle, and I have the area of the shape. 16, 11. So 216 square centimeters. Okay? All right. The next problem we were doing was 4 different problems on distributive property. And remember, I say this one's going frontwards and the other ones were going backwards. Okay, so this one ends up being, 3 times 8 minus 3 times 2z. And the answer for this one is 24 minus 6z. This one, they wanted us to sort of factor out a number that goes in both. Again, that's like simplifying a fraction where you find a number that fits into the top and the bottom, numerator and the denominator. We're finding a number that fits into this term, 2y squared, and this term, 5y. And the only thing I find is that y goes into both. So I pull that y out, and I say y goes into this 2y times, right? Because y times 2y is 2y squared. And y goes into 5y 5 times, because 5 times y is 5y. So we're sort of, that's factored. Okay, they say use distributive property. I would prefer they say I factored the y out of this expression. And I would say I use distributive property to distribute that 3 times each of these terms. Okay, so I'm going to factor this. What goes into 5z squared and 15z? I think I'll give you a hint on that first video. Both 5 and a z goes into both those. And remember yesterday we were talking about when you use z's now as a mathematician, you put a little line through that z. Okay, not being fancy. What you're doing is making sure that no one confuses that z with a 2. Okay, all right, so 5z goes into 5z to the second power, z times, because 5z times z is 5z squared. And 5z goes into 15z 3 times, because 5z times 3 is 15z. Okay, now the second part of that problem, I believe they wanted you to substitute y equals 3 and z equals 4 and see what the answer is. Okay, so let's pretend y equals z. I got 3 times 2 times 3 minus 5. What's 2 times 3? 6. What's 6 minus 5? 1. What's 3 times 1? 3. Okay, 24 minus 6z. If z equals 4, I have 24 minus 6 times 4. What's 6 times 4? Well, that's 24 too. 24 as well. 24 minus 24, a donut. Oh, I'm getting hungry now. I'll bring my vaccination card down to Krispy Kreme, get a free donut. Okay, all right. Yeah, you ever go in Roner Park with mom or dad and they've already had their vaccination? Tell them to bring their card and go buy Krispy Kreme. They give you a free donut for getting the vaccination. The rest of the year. Cool, huh? Okay, 5z times z minus 3. If z equals 4, that's 5 times 4, not 54. Don't write 54, right? Times 4 minus 3. What's 4 minus 3? 1. What's 5 times 4? 20. 20 times 1? 20. Okay, and if y equals 3, I got 2 times 3 plus 6 times z. What's z again? 4. So 2 times 3 is 6. 6 times, oh, I wrote, excuse me, 6 times z. If z is 4, 6 times 4 is 24. I went ahead and wrote 24. Oops. It should be 6 plus 24 in the parentheses, which is 30. And what's 2 times 30? 60 on that one. All right. All right. 856. Another set of box and whisker plots. And we were asking questions about the schools represented in the box and whisker plot. And one of the things they said is, which school is the K-8? Okay, and one of the classes, we had time to talk about this yesterday, decided that school A is the K-8. Why? Because it had kids that were 5 years old and kids that were 14 years old. Okay, so we're going to say school A on that one. How about, does that school have more students in grades kindergarten through second, third through fifth, or sixth through eighth? Okay, and it looks like that half the kids are in between 6 years old and 9 years old. Okay, 25% of the kids are between 5 and 6. That's probably kindergarten. So a fourth of the kids are kindergarten, and half the kids, or 25% of the kids, are between 6 and 8. I'm going to say that's between first and third grade. So I'd say it has more kids kindergarten to second on that. Okay. And that's why. Okay. But that's a close call there. All right. With B, it says, what does the box plot for school C tell you about 11-year-old students? School C, half the kids are between 11 and 12. Remember, each of these is 25%. The box represents half, the middle half. Half the kids in that whole school are between 11 and 12. They're 11 years old, right? How many students are in school C? You can't tell. You don't know how many kids are in. You know how they're divided. You know that half of them are, less than the line inside the box, but you don't know how many. That could represent 1,000 kids. It could be 10 kids. Okay. All right. 8-57. We started doing that, and then we were going to multiply. Remember, when you divide fractions, the first number stays the same. You multiply instead of divide, because multiplying fraction is easy, and you flip the second number. So instead of 6/5, I want 5/6. Now I'm going to simplify this because I recognize there's a 5 in the bottom and 5 in the top. So I replace those with ones. So all I have is 17 times 1, 1 times 6. 6 goes into 17 twice with 5 left over, right? Because 6 times 2 is 12, and 17 minus 12 is 5. So I did that. Okay, you go divide 6 into 17 and show your work. If I did that too fast, and I probably did. Okay, remember we were talking about you can't divide with the decimal outside the box. So we ended up with 328 into 1,476. Okay, and I believe this is going to go 4 times. And so I'm going to put a 4 there. I'm pretty sure about this. 4 times 8 is 32. 4 times 2 is 8, plus 2 is 10. Plus 3, sorry, is 11. And then 4 times 3 is 12, plus 1 is 13. Okay. And I get 164 as my remainder. Now I recognize that that is half of that. Okay. So you can have your answer be a half, but since this was a decimal problem, I'm going to add a decimal, bring it up, and add a 0, and know that 5 times that is going to be a perfect fit. Okay, so 4.5 is your answer on that. Remember on this, we're using the C method. 79 tenths divided by 44 fifths. Smell my feet. 79 tenths times, and I'm going to flip the 44 fifths to 5 44s. And again, that helps me because 5 goes into the top once, goes into the bottom twice. 79 times 1 on top, and 2 times 44 on the bottom. 88, 79 88s. You're done. Okay, we figured out that the pattern here was the difference between the first 2 numbers is 2, second 2 numbers is 4, then 6, then 8. So 21 plus 10 is 31. 31 plus 12 is 43. 43 plus 14 is 57. So the next 3 numbers are 31, 43, and 57. And it's going up by the next even number, you can say. Okay, that's one way of describing it. All right, prime factorization and greatest common factor, least common multiple. Remember the greatest common factor of 7 and 9, we talked about it, we didn't write it down, is 1. That's the biggest number that goes into both. The least common multiple of 7 and 9 is going to be 63. That's the product of the two, because one of them is prime and it doesn't fit. Okay, 15 and 12, I can go 3 times 5 here. I can go 3 times 4 there. The 4 is going to turn into a 2 and a 2. But 3 ends up being the greatest common factor, finishing up the prime factorization. So the greatest common factor is 3. That's the biggest number that fits into both. Now, what's the least common multiple? Well, 15 and 12 both fit into 60. Okay? All right. That last problem, that was a doozy, but hopefully you found that the answers to checkpoint problems are in the back of the book. Checkpoint, that's checkpoint 8, right? And it's the first part of A. All right, so it's going to have all of these answers and how to do them. Okay. All right, ask your teacher if you need help on that. Again, that is a long homework. We had a long video to start, long video for the answers. I kind of rushed it at the end there, huh?